In this video, we will examine how the diagnostic design prepared in Express can be enriched and ultimately used within DSI Workbench in any production or maintenance environments. But first, we will start with a very brief orientation of DSI's tool suite, as it facilitates a process that we describe as Integrated Systems Diagnostics Design, or ISDD, by referring to this chart to describe the generic flow of relevant and interrelated design information within DSI's ISDD tool suite. Express, which is our flagship diagnostic capture, modeling, and analysis tool that not only creates diagnostics that can be used in different environments, but also provides a savvy for assessing your design's capability to support superior diagnostics by producing unmatched feedback about where you can improve the design. Moving up from Express, you can export the data from Express to run in Stage, which is our simulation-based analysis tool. Here's where many sustainment assessments over time that consider replacement from prescribed maintenance activities can be produced that are directly based upon the diagnostic design of your system as described in Express. Also integrated within Express is a FAMICA Plus module, which allows you to take FAMICA data that you've either described within Express or have imported from any other standard FAMICA tool and import it into Express and merge it with the diagnostics to get a true diagnostics-based FAMICA. In this manner, you establish a mechanism that greatly simplifies and reduces the task to make future updates to your FAMICA over the development or sustainment lifecycle. This is a trivial process within Express because you just move to little areas and make a few changes, and it automatically propagates through the entire subsystems and system design. But what we'll be focusing on today is the diagonal line down to the right from Express. Express running through the runtime authoring tool to DSI Workbench, and DSI Workbench being integrated with the history and feedback module. As we look more closely at this seamless integration, notice that there are two sides to this slide. On the left we have the two tools that would be used during development, and on the right we have the tools that would be used during runtime. During development is Express, and then the runtime authoring tool. Express would be used by engineers, systems engineers, logistics personnel, etc. And the runtime authoring tool takes the diagnostics you developed in Express and allows you to attach different views of the design. These additional views can be any visual aids or documents, so that data as well as gathered procedures, videos, photographs, and many other things you want to add to the diagnostics will enrich the maintenance or troubleshooting experience, making it more robust, yet easier to use for the technician. So this runtime authoring tool, or RTAT, would be used by a systems engineer or even a technical writer, someone who's gathering together and organizing all of this data. It is also our middleware that allows you to take Express diagnostics and reformat it for other formats. So it's a reformatter and a data organizer. It's all facilitating work. Then DSI Workbench is the actual tool that the technician would be using in the field, either for maintenance or production. It takes the data that was created in Express and then authored or extended with procedures in RTAT and allows the technician to actually perform diagnostics at a consistent and high level. And it works in several ways. We will look mostly at what we call guided troubleshooting, where it's walking you through your diagnostics one step at a time. But that's certainly not the only way Workbench has been designed to work. DSI Workbench also integrates with test executives to load their test value parameters or test results information using a variety of files, including the two main IEEE standards, PDEL and ATML. And so it can take the test executive's test results and automatically process them rather than having you have to step through the same diagnostics manually. And then you can do additional troubleshooting using guided if you wish. So you can mix the different approaches, import test results files, and then continue with any remaining manual troubleshooting. You can also enter tests in any order if you wanted to go through and just perform tests that you know are useful that the diagnostics hasn't been optimized towards. Then finally, the Workbench History and Feedback module, which is closely integrated with DSI Workbench, tracks data that has been entered in DSI Workbench to provide information to management, engineers, and technicians. Management because it's able to track performance and other issues over time. Engineers because you can use the feedback if you're regenerating diagnostics and you want to make some improvements. And then the technician because you can actually use your history to extend the diagnostics that you get from Express to be able to handle things that the diagnostic engineer wouldn't be able to take into consideration. Now, targeting specifically the history and feedback module. The three major benefits of having this module working with DSI Workbench is, first of all, you have a fully integrated database, which is tracking all of your ticket numbers, diagnostics, test results, replacements, and everything so that you could use that for a variety of analysis tasks. You can generate reports on it to use for logistics planning, to recognize trends, etc. The second major advantage is that we've got a built-in report generator that automatically generates certain reports. So you can see, for example, per UUT, how many of the tickets have resulted from workstation issues as opposed to manufacturing defects, as opposed to just wear out of a part. You can do the same thing with average ticket times, open tickets, and rework cycles. So we have a variety of reports that we've pre-implemented using this database. Of course, because the database is there, the database is stored in a standard backend format like SQL Server, MySQL, Access, Oracle, or whatever you need it to be, because we can absolutely customize it to any database. Because it has this generic backend, your own programmers can easily create reports, drawing from the data as well. And so you really have endless reports, but we've built in some of the ones we think are useful to everybody. And then finally, the third major benefit is what we're referring to as historical resolutions. Whenever you finish a job within a diagnostic session in DSI Workbench, you enter what actually was the cause of the issue. It may be the replacements you did, or that there was some improper documentation, or test equipment wasn't being hooked up correctly, etc. Stores them within the database, and then these can be used to extend the diagnostics possibilities within Workbench. Lastly, let's talk about the two types of diagnostics available in DSI Workbench. One is the model-based diagnostics, and the other is the empirical diagnostics from the database. The model-based diagnostics is displayed on a panel called Primary Suspects, and it lists all the suspected items along with the root failure mode or functional causes of failure that have been isolated by the diagnostics up to a certain point in time. The resolution history panel, on the other hand, is the empirical diagnostics. What it's doing is for the same tests that have been failed in past, the same test sequence, or what we call a test signature or fault signature. For that same fault signature, it's looking up previous resolutions and listing those, and it's tied to the test. So both of these lists start out large, and as more test results are processed, they get smaller and smaller until only the things that relate to the current fault are listed. So the empirical diagnostics are pulling resolutions from the database, and that's where you can get things that were outside the scope of normal engineering. The test station failures, the manufacturing defects, etc. The empirical diagnostics are good at extending what the engineering diagnostics normally can't find. On the other hand, empirical diagnostics are only limited to failures that have happened before, and that's why the model-based diagnostics are still crucial. They're excellent at identifying first-time failures, and also they've been fine-tuned usually to identify critical failures, common failures, or important failures. So you have the engineering diagnostics and this empirical diagnostics side by side, so you're covering all bases. That is the basic of what we're going to be demonstrating in the next video in this database capability and how it works into Workbench.